Now, phylum Nematoda. These are our roundworms. Comes from Greek nema, which means thread, and ode, which means like. So they're thread-like, but they are roundworms. You can see here that they are roundworms. They're in the domain Eukarya, kingdom Animalia, phylum Nematoda, and we have class Adenophoria and class Sacernentia. There are thousands of them. There are more than 15,000 known species, but there are thousands in a single handful of soil. And some species of roundworm contain more than 27 million eggs at one time and can lay more than 200,000 of these in one day. They don't even think we've nearly discovered as many roundworms as there are. You see here whipworms and pinworms, pinworms are the most common roundworm in the United States. They live everywhere, even extreme habitats like ice and hot springs, and they live in or on almost every animal or plant alive today. They are very abundant, as we've said, in soil, where they feed on bacteria and detritus. They are unsegmented, bilaterally symmetrical. They are trypoblastic protostomes. They have the 3 germ layers, and the first opening that develops is their mouth. That's what protostomes means. And they have a complete digestive system. They do have a pseudocoelom, which is a false body cavity that's incompletely lined with mesoderm, and it provides a space for the internal organs and serves as a hydrostatic skeleton. The diversity of roundworms, the parasitic roundworms, you've got Ascaris, which is an intestinal roundworm. You've got Trichinella, which causes trichinosis, and humans can get infection from eating rare pork that's infected with it. Filarial worms, or heartworms, that dogs have. And then Wuchereria, which causes elephantiasis, and the vector here is mosquitoes that transmit the disease to humans, and the limbs will swell to monstrous sizes. As far as the support system, they have the cuticle, and it's the closest thing they have to a skeleton. They use their cuticle to support, and for movement, it allows movement and shape changes because of the hydrostatic skeletal system. If you see one move, it looks like it's just thrashing about aimlessly. It can only bend its body from side to side because of the muscles that are just under the epidermis that are aligned longitudinally from the inside of the body. Those muscles are activated by 2 nerves that run the entire length of the nematode. There's one on the dorsal surface and one on the ventral surface.